So let's get started. So this week is our last week on teaching, and basically this week we will provide a revision. So I will give a brief revision on Part A, and then Professor Rodman will give Part B. So before I give a revision, I will introduce mention a bit about the exam. So exam 3 hours, and you bring your calculator. And during exam, so we'll write your student ID. Bring your student ID as well. And so the exam format is like still material covered Part A, Part B. And so Part A is 40 marks, Part B 60 marks. So then the final exam is worth 70 out of your final grade. The rest 30% is basically your continuous assessment. And this is the Part A normally is 8 questions, Part B is 4 questions, but it may vary. Okay, so there is a exam folder, so which in your Moodle site, so they provide some past exam papers and also our slides. So this is the today's lecture. We're gonna first give a quick review on Part A, the topic, what we have studied, and then we see a few examples from past exam papers. So Part A, we basically have 12 lectures. So we start introducing MATLAB basic programming from lecture 2. So the first thing we introduce is assignment operator. So assignment operator is basically equals to, in mathematical point of view, is equals to, but here it's not equals to, it's assignment. So that means we assign B to A, okay? And we also introduce these arithmetic operators, plus, minus, multiplication, division. And there is some operator precedence, so there is some priori. So the priori that we always remember is bracket first. So what happens inside brackets, that's where you do the computation first, okay? And then followed by the priori, followed by power, multiplication, division, plus, minus, okay? So this is the arithmetic operators. And we also study some building function, cosine, sine, exponential, square root, log, okay? So this, I think, up to now, more or less, you all exercise the majority of the building function in your MATLAB lab. So, and then we cover the topic matrices. So in matrices, we introduced the 2 basic operator. One is column operator. So the column operator is normally, we use column operator to define a matrix or a vector, okay? So the column operator, for example, we normally put a starting value, ending value, and separate with column. So normally in between we put this step size, okay? But sometimes if you didn't have this step size, like this, starting from 1, ending from 5, no step size, the default is 1, okay? So that is column operator. And the second operator is link space. Link space, so it's different from column operator, although both of them are used to generate a vector. So link space, for example, how to use it is to say, for example, 1 and 5. So you give 3 parameters. The first parameter is starting from 1, ending from 5, and equal space with 5 elements. This 155 is equals to create a vector 1, 2, 3, 4, 5. And this vector match this command. That means start from 1, ending from 5, with 5 elements, equal spaced. Okay? So this is link space. And then related to matrices, we have a few building functions. For example, size. For example, A. Giving you A is a matrix, 2 rows, okay, 3 columns. The first row is 1, 2, 3. Second row is 4, 5, 6. So this A, I wrote here, is like 1, 2, 3, 4, 5, 6. And if you say size of A, this will give you what? This will give you 2 values. The first value is row number. So you have 2. Okay, 2 rows. And then followed by column number, 3 columns. So this is the size the building function will give you. If you see length, okay, so whatever smaller is 2 and 3 will give you 2 because 2 is smaller. Okay, so this is the length will give you, and then zeros. For example, 2, 2. So that means you create a matrices 2 by 2, element all 0. Okay? And ones is also create a matrices 2 by 2, for example, all element are 1. And I is just diagonal matrix. So this is matrix. Matrix also we talk about addressing, indexing. So for example, you can grab any element from a matrices, from a matrix. And simply, when you grab an element, you just put the row, the number of row that you, the element. For example, I want to grab this one from A. So you say A, you want to grab 1. So what's the row number? 1. What's the column number? 1. So then A, row number 1, column number 1, and giving these indices, then you can grab the corresponding the element from that position in the matrix A. So then the matrix, we study the element-wise operator. For example, two matrices multiply each other. A, B are same size. When they multiply each other, they must be same size. So A, B, when you do multiplication, you what we normally do is put a dot there. It means element by element multiplication. Also division, okay, that way. So this is matrices. And then the lecture 4, we studied plot, okay. So this building function is quite useful in your basically all the labs and assignment, how to plot things. So basically plot x, y is x versus y, okay? You can also plot multiple curves altogether. X1, for example, you just list x1 versus y1, x2 versus y2, and so on. So when we plot, we can also followed by the data type. For example, plot xy. I want a blue curve, okay, and a dashed line. So you can point out the line color And the line style, even the data marker, for example, a circle or a dot. So this is the plot. And also for plotting a curve, you can put a label, okay, and title, legend. And the grid is basically you can write grid on. That means add grid. Okay, so this not examined is a 3D plot. So basically, 2D plot. 3D plot we mentioned a bit in our lecture, also in our slides. Okay, but it won't be examined. So, and then lecture 5, we talk about how to create M file. Okay, so this M file, when you create an M file, up to now, I'm sure 100% of you all know how to create an M file. Okay, and some built-in functions, for example, input, okay, and display. So input, note that input, you can input a number, okay? So input a number. So this will say input a number, but if you input a string, it's gonna be different, okay? You said string. And then you have to specify input is S, okay? An extra argument so that you can input string. It's different from input number. And display is very easy. Display followed by single quotes and some text or some numbers. So pause clear CLC. This is normally clear CLC is at the beginning of your MATLAB codes. You all put this. And the documentation, self-documentation. And then lecture 6, we mentioned how to create a function. Okay, how to create a function. Up to now, I'm sure after so many labs, how many labs you have? 9 labs and or assignments, you are very familiar with this function, how to create this function. So when you create a function, you open an M file, you write function, followed by output, function name with input. This is output argument, followed by function name with the input arguments. Output argument, input argument, you can all have many, okay, multiple output argument, multiple input argument. And then follow this. This is called a function declaration, the first sentence in your function, and followed by assign output some computation. This is the function. This is a basic MATLAB function. So later we talk about the function handle. Okay, it's another type of that function that you can use. So lecture 7, followed by lecture 6, we talk about input-output. Input-output, not examined, is the ASCII codes, that table. Okay, so then the most important thing that input-output we talked about is fprintf. This fprintf is formatted printout. So the difference between sprintf and display is display something. Can be text, can be number, okay? That you just directly displayed what is inside these single quotes. Well, formatted printf is you can not only print out, but also you can define the format you want to print out. How many precisions, how many decimals, okay, decimals. So this fprintf is more, how to say, more sophisticated than DISP. Okay, so for example, fprintf, you can print out, for example, 10 width okay? 2 digit after in the decimals, two decimal places, F2. Okay, so you print out 2 in 10 space. For example, this is 10 space. You print out 2 with 2 decimals. Okay, this is 10 space. Print out this 2 in 2 decimal places. So this is fprintf, and also we studied fopen, fclose. That is when you open a file, write something, or read something, and then you use fclose. Fopen, if you use, then you must use fclose at the end. And fgetL is get a line from the file. And fgetL, remember, every time you can only get 1 line from the data file you read. And what it return fgetL, that line will be a string. So if the line is data, you must use string to data to change that line from a string to data. And this is the input-output. And then the next lecture we studied decision-making. Decision-making, basically, 2 operators we studied: relational operator and logical operator. Relational operator means compare. A and B can be, this normally can be matrices, can be matrix with a scalar, or can be both matrices, under the condition of less than, greater than, or equals to, and so on. So relational operator normally return you what? Return your logic data type. Remember, this is the, we studied the data type like double, okay, string, and logical. Logical data type is like saying you have 0 and 1, but these 0 and 1 are not double data type. This 0 and 1 means A compared to B, and this comparison is true or not. If it's true, what you use 1 to represent the comparison is true. Otherwise, you use 0. This means false. So this is the logical data type and relational operator. And the logical operator and or not. Okay? So this logical operator normally combined with the relational operator with some comparison, and whether it's multiple comparison, and then in between you can put and if multiple condition all holds, or one of them holds. Okay? And then we talk about if and if-else if. So if statement normally is you can only put one condition. One condition. If some condition holds, then we do something, and end. So using if statement, you must put an end to match. Okay. So if-else if is when you have multiple condition, more than 2, or even can be 3. So this is if-else if. And then lecture 9, we study loops. Loops, we studied for loop and while loop. And this for and while loop should understand the difference between them. So normally when you know exact the number of iteration, which loop you're using, you use for loop. Okay? So then you know the number of iteration, you use for loop. While loop, you don't know the number of iteration. While loop normally followed by condition. So as long as the condition satisfied, we repeat, okay? Otherwise, we exit. So this is loops. And then lecture 10, debugging, we give 3 examples of troubled MATLAB codes and let you find out where is the mistake. So basically, we introduced F11 and F10, which is a step-in debugging and step. They are pretty much similar, debugging line by line. The step-in is when you have a function, you can go into function. While step, we're not going inside the function. And then the lecture 11 and lecture 12 is our two last lecture in part A. Lecture 11, we talk about advanced function. Basically, you talk about function handle. Function handle, what is function handle? Function handle is to saying that give a variable, and this variable was assigned as a function handle or working as a pointer to point to a certain function, and this followed by function name. So that means this fn is a variable and working as a pointer to a sign function. And when you say fn0, that is equivalent calling this function with input 0. Sorry. So this is a function handle, of course, followed by this address sign, followed by a function, built-in function. I can be anonymous function. When you do an anonymous function, okay, this format becomes input, for example, argument is x, and then followed by the one-line computation. For example, x, in MATLAB I should say x power of 2 plus 1, something like that, okay? This is a function handle for anonymous function. Anonymous function normally is a one-line computation. This computation you can define yourself. And also we talk about the variable scope and workspace. Basically, variable scope divided into two workspace. One is called a base workspace, and the second is called a function workspace. So what's the difference between them? What you created through function, the variable stayed in function workspace. And in MATLAB command window and all the M file that you created variable stay in base workspace. So they seldom talk to each other. This idea is based upon variable scope. And then the last lecture, we talk about errors of MATLAB. So we'll first talk about round-off error. Round-off error is, for example, some real numbers. For example, 1 divided by 3 in MATLAB. So 1 divided by 3 is equals to 0.333 and repeat infinitely. So this kind of long data, MATLAB cannot store properly. So they have to truncate, not truncate. So they have to store in up to certain precision, okay? Not 100% accurate. And that will cause round-off error, okay? So this round-off error is different from truncation error. Truncation error is a sign-Taylor approximation, for example. You have n infinite terms, but then you only take first 3 terms. That is truncation error. And round-off error is some real number that MATLAB cannot store properly, so cause this error. So these two errors are different. And round-off error is an error that generated by MATLAB. And truncation error is a man-made error. So you, for example, you can make it because you only take first few terms of a sign-Taylor. So then we talk about the overflow and the flow. Overflow and the flow. Overflow means if you want input a value A, for example, the absolute value is greater than real max. Real max is maximum real number MATLAB can support. If your input value A, take an absolute. If that absolute value is greater than real max, then you cause overflow. And if your input A absolute value less than real mean, you cause underflow. Okay? So overflow, normally MATLAB will return plus minus infinity. It depends on your input argument, the sign. So input is a positive sign, it return infinity. If it's negative sign, negative infinity. Underflow. Underflow normally is the input is too little, and then the MATLAB will return 0. So, and then the last topic we studied in part A is how to write fast MATLAB codes. Is we use pre-allocation. Normally, when we deal with vector matrices, at the beginning of the MATLAB codes, for example, A, you can pre-allocate zeros, for example, 3, 3, okay? So you pre-allocate a matrices, and then you can use for loop or other things to update each element in that matrix. So this is pretty much the, we still have, okay, the topic we covered. And so this is basically a detailed repetition of that. I will skip these few slides. And now let's, I choose a few examples from the past exam paper. Basically is 2011, semester 2. So I give you 1 minute to read this A1. A1 is very easy. Can you see it? So basically, A1, the red part, is the solution. Okay? So A1, you can ask me which part that you want me to discuss. Okay? Which A, B, C, D, which one you feel confused? Oh, okay. Very easy. So I will briefly tell the idea. I will not do the computation, but I'll briefly tell you an idea. For example, x from 1 to 4 is 1, 2, 3, 4. That is x. And y is 2, 3, 1, 1. And the first question is ask you each element to the power of 2. This means each element to the power of 2. So x is 1, 2, 3, 4. Each one take power of 2. Okay, so that's where you get. And the second question is x dot multiply y. So is x multiply y element by element. So that means 1 multiply 2, 2 multiply 3, and so on. Here what you get. And the third is x multiply y. This is transpose. This means transpose. Okay, so that means 1, 2, 3, 4. We'll multiply a column vector, 2, 3, 1, 1. And each element multiplication and sum them. So then you get value, 15. And the last one is B is 3. So this is telling you x is 1, 2, 3, 4. You find the element which is greater than or equals to 3. So grab the element. So it's by basically last 3, 4 satisfy this condition. Okay? So anything unclear? Anything you want me to mention a little bit more? Okay, this is question 1. So followed by question 2. Question 2 is testing you at printf. So there's a mistake here. Okay. So percentage 10.2 f. So the question A2 is asking you basically printf to print out A. A is an integer. A is 2. Okay, f print f, print out A. This is 2 and this is also 2. But in different format. One is percentage D. D is just integer. So we print out 2 directly. And percentage F, fixed point printout, is 2 followed by 6 0. In between you put a dot, okay? 6 decimal places. And the next one is a printout pi, okay? Is 10.2 F, printout pi. So what does that mean? That means 10 spaces from beginning to the end of printout and 2 decimal places. So it's 3.14, okay? And then followed \n. \n means a new line, start a new line after printout. Okay, this is a very easy question. And then the third one also we test the plot. Plot is giving you x, 1, 2, and you plot x versus x to the power of 2. So basically 1, 2, and x to the power of 2. 1 to the power of 1 is 0. Is 1. So you print out in the circle. Okay? And 2 output is 4 here. Print out another circle. Okay? So this is the plot. And question A3, I give you 1 minute to read. And if you didn't understand which part you want me to mention a bit more, you just let me know. So A3, I give you 1 minute to read. So which A, B, C, D, E, which one you feel that is confusing? So the first one is very easy, right? Create X using linspace. Linspace we have already mentioned is starting value 10, ending value 1. How many elements? 4. You have 4 elements. So you put 4 in. This is the linspace. And then the rest is testing building function, 0 and 1s. Zeros with the size of X. So that means you create same size as X, but the element of 0. Here is element of 1. And the D is a grab element from X. This is the 3, 2, 4 is the indices. So that means you go in X and grab the third element. So it's 4. So put 4 here. Second element, 7. This is the fourth element, is 1. So this is the grab some elements from the matrix X. And the X grab the last one, so it's 1. Okay? This is the matrices indexing. And the last one in A3 is create B column vector using column operator and transpose operator. So it's basically it's from 10 to 1 with the step -3. And then you can do a transpose here. Okay? Either you do the matrix prime or you just use the building function transpose. So that is A3. A3 is testing matrices, matrix index and building function. And I'll give you 1 minute to read A4, A5, which is very easy. So A4, which part you feel confused? So A4, 3 questions, A, B, C. So the first question give you a vector A and a B. B, note that you use a logical. So logical is a building function. Logical, this building function will change this 0, 1, 1, 0, 0 from data type, from double to logical data type. So that what does that mean? So 0 means false, 1 means true. Okay? And if you use B as index, you see A using index of B. So that will return the value in A, the element in A, which are in true position. Okay? So these two. So that means the second and the third position. So 6 and 8. Okay? So that is to test you use a logical sequence as an index. Normally you use a logical data as an index that will return the value in that matrix which are true. Okay? So this is the first question. Second question is function handle. Function handle is let Fn as a function handle that handles sign function. And what is the Fn0? That means what is the input when the input is 0. Fn means a function handle that handles sign. With the input 0, that is equivalent to compute sign 0. So you get 0. And the second building function is function handle Bn with the input 3. That means x now is 3. And what you compute is here. X plus 1. X now is 3. 3 plus 1 is 4. Okay? And A5, I will only talk about these two. Okay, these two is giving you a matrix Z, and you grab the element. So the first question is asking you 2Z, 2, then a column. Okay, that means this first indices means the row number. So you go to second row, and then the column means all column. Okay, second row, all column, that means 4 and 2. And here, the second question is go to Z, grab. So you see semicolon, and then end. That means this is a row number. If you see a column, that means all row and the last column. So you come here, all row and last column is this one, is 3, 2. Okay? So this is how to grab elements from a matrix. Okay, and A6 have 3 questions. Have a read. So this is testing overflow, underflow, and errors. Okay, so in MATLAB function, if you input 1,000 to the power of 1,000, that's a very big value. That is greater than real max. Okay, so when something input absolute value greater than real max, what happened? You incurred overflow. Okay, the input is too big, so MATLAB will return infinity. Okay. So then the second question B. Question B is also similar. Question B is to saying the input value is 1000 to the power of 1000, but with the minus sign. As I said, so what we really look at is absolute value. Okay, even you input a minus, you look at absolute value. Is that greater than real max? It is greater than real max. The real max is 3 to the power times 10 to the power of maybe 300 something. So this is absolutely greater than real max. So it's still overflow. But then your input have a minus sign in front. So return, MATLAB return minus infinity. Okay? How about the last one? Is testing about epsilon. So what is epsilon? Remember, epsilon means the smallest distance MATLAB can support. For example, 1 here, the next real number MATLAB can support is 1 plus epsilon. Okay, of 1. This is epsilon 1. This is the distance. Is 2e to the power times 10 to the power minus 17, something like that. So it's the smallest real number that MATLAB can support. But now he's asking you, what is the result y after compute epsilon divided by 10? So epsilon 1 is already the smallest real number that MATLAB can support. So epsilon 1 divided by 10, okay, it becomes 0 because this is the real number MATLAB can support, the smallest one, divided by 10 is beyond the smallest number MATLAB can support, so it's a 0. 0 plus 10 is 10. Okay, so this part is just 0. And the question 7, the first one is too easy. So second one I want to explain. Second one, A and B, is giving you 2 vector A and B and test you A double equal. A equals B or not. This is a logical comparison. Okay, so it compare each element in A and each element of B and whether they are equal. 2 and 3 they are not equal, so the comparison is false. You put 0. And 3, 3, they are equal, so you put 1. So 0 and 1s, that is means represent comparison result. Second is A equals B. That means assign B to A. So B is 332, then A is 332. So this is to test you equals to assignment, the difference. This is the rest relational operator and logical operator. These 3 you can compute directly. So I leave you as you can do it after class. This is very easy computation. And the last question, A8. Okay. So here is a mistake. So A8 is to telling you, giving you starting K, B, X, Y, and you have a while loop. This while loop K, starting from 14 greater than 6, and then you do this computation. So actually, so you do quite a few iterations. So the first iteration, for example, the first iteration is a Y. Y at the beginning is 3. 3 plus 1, you get 4. So you place this 4 here. This is a table. This red number is the solution. Is empty space that you can place your computation in. So the first iteration, 3 plus 1 give to Y. Y is 4. And the B is 1 here. And Y now is 4. Is 1 less than 4 is correct. So B plus 2. B is 1. 1 plus 2 is 3. So you put 3 here. And then you jump out from the if statement, compute X. 2 multiply X. X is 1 plus 1 is 3. So you put 3 here. And then finally, k minus 2. K is 14 minus 2 is 12. So you can go on. Okay? So this is the, I got 8 sampled questions from the past exam. Yeah, that's pretty much for today's revision. Any question, feel free to ask. Thank you very much.